Hey everybody, Mr. Gajewski here, and today we're going to talk about using the AC box method to factor quadratic trinomials in the form ax squared plus bx plus c. So let's jump right into it and take a look at our first example. So we're using the AC method. So we're going to multiply a times c, so 3p squared minus 5. That's going to give me negative 15p squared. And then I'm going to look for factors of AC whose sum is equal to b, in this case negative 2p. So when I factor out this negative 15p squared, the sum needs to be equal to a negative number. So the larger of the factors will be negative, the smaller will be positive. So let's start small. How about p and negative 15p? Does that equal negative 2p? No. How about, well, I can't divide 15 by 2, but I can divide by 3. So how about 3p and negative 5p? Does that give me negative 2p? Yes, it does. So what I'm going to do next is I'm going to take my a value, 3p squared, and my c value, negative 5. And I'm going to fill those in with the a value always going in the top left and the b or c value, always going in the bottom right. Then I'm going to take my two new terms and I'm going to fill those in. Does not matter where my two new terms go. They can go, I could have put negative 5p in the bottom left, I could have put 3p in the top right. Does not matter. Now I'm going to use the box method to factor. Now an important note about using the box method to factor is that you always want to factor along the left-hand side and the top of the box. I'm going to show you why in a little bit here. So what I'm going to do is I'm going to factor this top row, so 3p squared and 5p. Well, I can factor out a p. In the bottom row, 3p minus 5. Well, they don't have any common factors, so we can factor out a 1. I'm going to factor out the first column, so 3p squared and 3p. Well, I can factor out a 3p. And then negative 5p and negative 5. I can factor out a 5. Now, if we look at our original equation here, we see that we're going to need a negative here. So the question is, which of these two values, 1 and 5, is going to be negative? The key here is to look at the box that the factor is bordering. So 1 borders a positive box, p borders a positive box, 3p borders a positive box, but 5 actually borders a negative box. So we're going to make that 5 a negative 5. And earlier I mentioned we always want to factor to the left and to the top of the box. The reason being is because if we did not, and I factored to the bottom and the right, we would have two factors bordering negative 5. And I would be inclined to factor those as negatives. But in reality, when I go to multiply those, if I were to multiply two negatives, I would get a positive at the end here. I'm trying to get a negative. So let's go ahead and let's rewrite our factors as the product of two binomials. So 3p minus 5 and p plus 1. If I'm not sure that that's my answer, I can always multiply to do a check. So 3p times p is 3 squared. 3p times 1 is 3p. Negative 5 times p is negative 5p. And negative 5 times 1 is negative 5. Go ahead and combine like terms. And we get 3p squared minus 2p minus 5. And that matches my original trinomial. So my final answer, and I'm going to rewrite it in the bottom left, is indeed 3p minus 5, p plus 1. And then we go ahead and we circle that for our teacher to see. Let's do a couple more together. 2n squared plus 3n minus 9. Let's multiply AC. Negative 18n squared. And again, pay attention to those signs. Factors of negative 18 with a sum of 3. So I need the bigger factor to be the positive here. The smaller will be the negative. Well, how about negative n plus 18n? Nope. Negative 2n plus 9n does not equal 3n. How about negative 3n plus 6n? Yeah, that's going to work. So let's go ahead and let's put A in the top left, C in the bottom right, and we'll fill in our two new terms in the bottom left and top right. Factor the top row. We can factor out a 2n. Factor out the bottom row. We can factor out a 3. And because it borders a negative 3n, we'll make it negative 3. Factor out the left column. Well, I can factor out an n. And I factor out the right column. I can factor out a 3. And because it borders a positive box, we're going to leave it positive. We're going to rewrite my factors as two binomials. So 2n minus 3 times n plus 3. Now, if you want, you can always multiply to do a check. We're not going to do that for our second example here, but we will, as always, circle our final answer for our teacher to see. Let's do one last problem together. All right, AC method. A times C, that's going to give me 12n squared. Factors of 12n squared, whose sum is negative 8n. So two factors of a positive number whose sum is negative. I'm going to need two negative factors here. So negative n plus a negative 12n. Nope. Negative 2n plus a negative 6n. Negative 2n plus negative 6n, that does give me negative 8n. So I have all my terms. A in the top left. C in the bottom right. And my new terms fill in the remaining boxes. Go ahead and factor. Well, I can factor out a 3n there. I can factor out a 2 here, bordering a negative box, make it negative. I can factor out an n, bordering a positive, leave it positive. And here I can factor out a 2, bordering a negative. So let's make it negative. Go ahead and rewrite my factors as two binomials. Minus 2 times n minus 2, and we circle our final answer. That is it for today. That is using the AC box method to factor quadratic trinomials in the form ax squared plus bx plus c. I hope that helps. If you have any questions, let me know. If not, I will see you next time.